G'day everybody, where's Wally here? Now this is a big lesson today on the strawman fallacy from the biggest maker of straw men, the tallest flatty around the globe, Gigantor. So many flatties just rush to his channel to pat Gigantor on the back, which is no mean feat seeing how tall he is, but not one spotted the glaring fudge, the huge straw man. Okay, well to be fair, they probably saw it, but they didn't dare say anything negative, or otherwise you get privated, just like most of us have. So at 50 seconds I had to stop because he's mentioning hotness of the sauce, but then he goes on to talk about the weather. Are you having a laugh, mate? Gee, I know Scobles is the scientific unit for the measure of hotness of a chili sauce, but yeah, goodness.
And here we've got a curved piece of skirting board. And of course I've had to stick this on here because gravity won't hold this down on a slope.
Okay, Nick, hang on a second. So you had to stick the bottle to the curved timber because gravity won't hold it down, yeah? Gravity's doing a fine job with the red bottle, though, isn't it? I think what you mean to say is that gravity was pulling it right off the board because the angle of the board was too steep. Yeah, I'm sure that's what you meant to say. And the direction that the bottle was being pulled was towards the centre of the earth, yeah? Look, I think you better check with Riley as to what is your independent variable. You know, the angle of the base, I think that's what you were doing. Nice gravity proof, Nick.
It's debatable whether we can tell from this position whether that bottle is on the right is angling away from us.
Something he gets right. Yes, you cannot tell that the green bottle is leaning away at 25 degrees. I hope all flatties take note of that.
On a globe is that the higher we go, the more we have to look down to see something going beyond a curve. So but what we can see here is that as we rise up, the horizon or the surface.
The higher we go, we have to look down more. Notice that even on the flat earth horizon, it's dropping as the camera goes up. You can tell because the car wheel is more visible, the peak of the neighbour's house is more hidden, and Nick actually has to angle the camera downwards to keep the horizon in the centre. So this piece of sleight of hand trickery is to keep the angle of the camera down to make it appear to stay in the centre of the frame. Oh, and I am starting to smell straw. Are we down on the farm, or is there a straw man coming?
So all you have to do is take this observation and go and make an observation across a real surface of water. It could be a lake, it could be the sea, and then make an observation from a low elevation like this, where the bottle on the left appears to be sitting on the horizon, and then go to a higher elevation. You could use a drone to do this if you wanted.
Okay, well let's try and test out Nick's claim here. Let's see what we can see when we get a little bit of elevation. And to do that, I just grabbed this nice little video, link in the description, from Bobby Shafto. And he's got the same boat, one from what, 97 feet and the other from 300 something feet. A little bit of elevation change. And let's just have a close look what we can see. And while we can't really see that much difference in what's behind the ship, it's what's at the base of the ship that really interests me. When it's down low elevation at 97 feet, you can't see the bow wave, but yet when you only get a few hundred feet higher up, have a look at that right at the front of the ship. Yep, there's a bow wave splashing along. So Nick, how can we see that? Oh, Nick, what is that on your neighbour's house over there? Is that a satellite dish? Well, that's an interesting direction that it's pointing, don't you think? Oh, and if you haven't seen Joss Lee's latest thing on satellite dishes and how that proves the globe, I've left the link for you down in the bottom. That's a real eye-opener, that one.
But with the green bottle on the curved surface, we cannot see that curved surface. Even if we angle down, we still cannot see that curved surface.
High enough to see the bottom of the bottle is higher than the ISS, which sees the horizon at a 20-degree angle. Now your bottle there is at 25 degrees, which means you have to be about 700 kilometres above the surface.
Make an observation near the surface and make another observation from higher up. This is all you have to do.
The next time you're on the ISS, you mean?
If you don't see the surface extending beyond the bottle or the proverbial ship, then that would mean it is curved.
No, Nick, that's called the Strawman Argument. It doesn't matter whether you can or can't see the base of something when it's over the curve. But what matters is that the base is hidden. Now check out this epic ship. You've got two ships, one in front of the curve and one is behind the curve. And of course the atmospherics are the same for both, so you can't blame the atmospherics.
We could find a way to get some kind of drone or aircraft or whatever and fly straight and make this comparison with a side-on view.
Well, of course you can't fly a drone that straight, because you simply can't fly it that accurate due to winds and everything else happens, unless of course you use a GPS, but that means you're using GPS based by satellites and it's all game over at that point anyway. Oh yeah, and another point is that whole drone thing, it's kind of a bit strawmanish, don't you think, Nick?
This is simply a scaled down demonstration of what we can look for.
So this is simply a scaled down version then, is it? So it's a model, you're modelling the real world? Well, let's have a good look at that. And this bottle is measured, it's at 25 degrees, and that's scaled to be on the curvature of the Earth, because you've got to use the actual curvature of the Earth. And if you do the maths, you find that 1 degree is 111 kilometres, so 25 of them, it gives you 2,775 kilometres from the shore. And it also means you've got to be about 700 kilometres high to see that base. So there you have it, guys. We're right at the big straw man that Nick made. He just said, oh, look, you couldn't possibly do it. That's because he's made it so exaggerated that made it really easy for him to say you can't do that, which is exactly what a straw man argument is. Game over. Thanks for playing, guys.